New Glenn explodes. NASA leans in on the moon base. Starship makes its 12th flight. Have astronomers found a primordial black hole? And in Space Bites Plus, flying a plane through a rocket plume to measure its pollution. All this and more in this week's Space Bites. So we had this week's episode completely in the can. It was totally recorded. Anton was working on the edit, and then life intervened. And so here we are with some breaking news that kind of changes everything for this week. And that is the news that a Blue Origin New Glenn rocket has exploded on the launch pad. This happened at the LC-36A launch pad at Cape Canaveral in Florida. This is bad. The explosion is gigantic. One of the largest explosions in the history of rocketry. This is a very big rocket, and there was a lot of fuel on board. And when it exploded, the fireball is just immense. We really don't know the damage that happened to the facility. Obviously, the launch gantry is probably a mess. The mobile transporter is probably a mess. But I mean, there are buildings, there are other rockets nearby. There's going to be a lot of cleanup work that's going to have to get done. Fortunately, there were no injuries. Everybody was outside of the safe area. And really, the damage is to Blue Origin's business as they're attempting to fulfill all of their launch commitments. So the explosion happened when Blue Origin was doing a hot fire test of a New Glenn. And we don't know what happened. We don't know what went wrong. Some people have analyzed the video frame by frame. Scott Manley looked at it and could see that the explosion started down in the engine area and then it went on to consume the entire rocket. And after a while, it's all just explosion. And so you can't see. We're going to share just a couple of frames that were captured by NASA Spaceflight, but you really should go to their video feed and watch because they caught the moment of the explosion from beginning to end. They've always got the best coverage of what's happening with rockets, both in Florida and in Texas. We got an announcement from Jeff Bezos that they're going to be investigating this and trying to get to the bottom of it. And so I think this is a story that is going to unfold over the weeks and maybe even months as we learn kind of what damage was done to the complex and really what damage was done to Blue Origin's business, because the next story I'm about to get into is really relying on Blue Origin. And now this next story, we had to completely redo it because NASA announced its plans to further explore the moon and begin building a lunar base. And this was going to heavily rely on Blue Origin's rockets. And they announced the first 3 missions that they're going to carry out in 2026. So they're Moonbase 1, 2, and 3. Moonbase 1 was supposed to be a test of Blue Origin's Blue Moon Mark 1 Endurance lander, and this would be a test landing on the moon to just demonstrate that this lander would work on the moon. Moonbase 2 was with Astrobotic's Griffin lander, and this would deliver Astrolab's Flip rover, which would be one of 2 rover systems that NASA was planning to deliver to the moon. Moonbase 3, which would be targeted also for 2026, would be the first payload for the Surface of the Moon initiative. This would fly on an Intuitive Machines Nova C Trinity lunar lander, and this would deliver the lunar vertex and some other scientific payloads to the surface of the moon. So this was the plan, and they're also proposing that they're going to deliver something they're calling Moonfall, which would be these sort of hopping robots that would explore the surface of the moon. Obviously, this is related to Skyfall, which was their plans to deliver helicopters to the surface of Mars, and helicopters don't work on the moon, so these would be propellant-based hopping landers that would explore the region around where some future lunar base would be. And then the plan is that these hoppers would end as the 4 corner posts of the future moon base for NASA. And so it's a cool idea. And, you know, I've covered these kind of hopping rovers in the past. It's a good way to get out there and explore the surface of the moon. And they've announced that Firefly has the contract for the Moonfall mission. And so there are a bunch more missions planned out for the Blue Origin lander. They're going to deliver the Viper rover as well as lunar vehicles. So Blue Origin was very heavily integrated into NASA's plans for the future. And you can see this hedging that they're doing as they're watching the delayed progress of what's happening from SpaceX, which we'll get to in a second. We've re-recorded this segment of the episode because the consequences of last night's rocket explosion are going to be wide-ranging, and I think we can safely say that these timelines are all going to be out of whack. I mean, we don't know when Blue Origin is going to be able to get their facility rebuilt, get New Glenn's on the pad, be able to launch NASA equipment to the moon. We don't know what the consequences are going to be for NASA, for their plans, for the rest of the moon base, even with other companies, other rockets. We just don't know. So that was the announcement from NASA, and now we're kind of waiting. So I expect in a couple of weeks, I'll be able to give you sort of a reformulation of what the new plans are going to be. But man, what a bad week for spaceflight. It's been a while since we talked about Starship. Do you remember that thing? Well, we saw another launch, and we had timed our recording last week so that we would be able to report on the Starship launch and then be able to record the episode, but then they delayed a day, and so we had decided we're going to hold off. So we decided we're just going to report on what happened with Starship this week. And so that's why we're the last of the people to report on what happened with Starship. So, but I'm sure you got a great explanation from Scott Manley and Marcus House and all of the other sites that do a great job of reporting on SpaceX. So this was the 12th launch of SpaceX Starship, and they had a ton of new things that they were going to test out. This was the V3 version of Super Heavy and Starship, and they were both carrying the V3 version of the Raptor engine. We had a Super Heavy booster with more thrust. We had redesigns to the propellant tanks. They went from the 4 grid fins on Super Heavy down to 3, but larger and beefier. Redesign of the hot staging. With Starship, they were also installed Raptor 3 engines. They made revisions to the heat shield, and this had docking ports. You've seen the simulations of what Starship looks like when there are 2 of them in orbit, and they're docked together, and I guess they're transferring propellant to a tanker. Then they're starting to build up the infrastructure for what that's going to look like. On Starship, they also had a whole bunch of dummy satellites on board to test how they would be deploying Starlink satellites in orbit. And then they had 2 Dodger Dog satellites, which were going to test out new technology for the Starlinks. And they took a page from the Chinese space agency on this one, which was that they built a way that Starship can take a selfie of itself. And so we got the deployment of the satellites, and they had cameras on board, and so they were able to take a picture of Starship from the satellite, which was awesome. And I wasn't sure that was going to work, but it worked out really well. But not everything went according to plan. The launch looked great. It lifted off from the pad, and once we saw the hot staging separation, the engines on Super Heavy cut off prematurely, and it tumbled back through the atmosphere and crashed into the ocean. Now, they were originally planning to have it soft land in the ocean, so they weren't going to try and catch it anyway, but this was harder than they were expecting. Then Starship fired its engines, made its way to orbit, but only 5 of its 6 Raptor V3 engines started up, but they still had enough delta V to be able to get into this suborbital trajectory that they were planning. Then they deployed the satellites, then re-entered the Earth's atmosphere, and once again landed in the Indian Ocean, kind of exploded when it hit the surface of the ocean, and that wrapped up another Starship. And so there's still a gigantic laundry list of items to do. We've got to see a successful capture of the new V3 Super Heavy. We've got to see a capture of Starship at all. And we've got to see orbit. We've got to see refueling. And a lot of this stuff has to come together before we see the human landing system ready to be able to carry astronauts to the moon. And the clock is ticking for both Artemis 3 and Artemis 4. So we've got a great story about this from Alan Boyle covering the entire mission. In 2019, astronomers watched a star in the Large Magellanic Cloud briefly brighten and then dim again. And this is a very common event. This is called a gravitational microlens, where you've got a background star and then something passes in front and distorts it with its gravity. But after astronomers did the calculations, they realized that whatever this thing was, it probably only had about 3 times the mass of the moon. And it could either be in the Milky Way, or it could be in the Large Magellanic Cloud, or it could be in the halo around the Large Magellanic Cloud. So either you've got a rogue planet that they're able to measure microlensing events from rogue planets down to about 3 times the mass of the moon, which is incredible. Like, microlensing is just an incredible science on its own, has discovered exoplanets just by watching how the light flickers from a star as a star and its planet are passing in front. But in this case, just something 3 times the mass of the moon. So what is it? Well, an obvious possibility is that it is a planet with about 3 times the mass of the moon, like a rogue planet. And we know that there are a lot of these things out there. We've seen Jupiter-sized ones, Saturn-sized ones. If you just sort of do the math, there must be even more of Earth mass ones and moon mass ones out there just drifting in the cosmos. So that's one possibility. And it could either be in the Milky Way or it could be in the Large Magellanic Cloud. But this third idea is that it could be some object that is in the dark matter halo around the Large Magellanic Cloud, that it is something with the mass of 3 times the moon that is making up the dark matter. And there is this theory that one explanation for dark matter is primordial black holes. So like right now, we can only get black holes through the death of a massive star. It collapses inward, its enormous mass pressure creates this black hole. And then you've got this black hole that can have, say, 3 times the mass of the sun, that can then go on and add more mass and eventually maybe become a supermassive black hole. But how do you get a black hole with 3 times the mass of the moon? Well, it had to have been formed at the beginning of the universe in regions of higher and lower density left over moments after the Big Bang. And you know, when we think about the explanations for dark matter, like maybe it's some kind of invisible particle, maybe we just don't understand gravity, but there's this other idea that has been sticking around and nobody can rule it out, and that it is primordial black holes, that the halo of dark matter around the Milky Way is made of black holes. And so if that's what this is, then we might be seeing a primordial black hole or something more boring like a planet with 3 times the mass of the moon. But still, that would be very cool. Got a story about this from Mark Thompson. One of the big questions in astronomy is which came first, galaxies or the supermassive black holes at the hearts of those galaxies? The two seem intertwined. Almost every single galaxy ever observed has a supermassive black hole at the heart of it. And one of the main jobs for James Webb was to try and figure out the history of galaxies and how they constructed themselves over billions of years. It was assumed that you would have these small dwarf galaxies as the building blocks. They would merge with each other, and over time you would get this larger, say, spiral galaxy like the Milky Way. They would find each other, merge into heavier black holes, and eventually they become supermassive black holes, merge with more black holes, but also feed on the material and eventually get to the millions, even billions of times the mass of the sun. Well, now astronomers have found what looks like a supermassive black hole without a galaxy. So the object is called Abell 2744 QS01. There's actually kind of 2 parts to this. There's the Abell 2744, and that's actually the foreground galaxy that is acting as a gravitational lens for this object that is behind it, the QS01. I'm just going to warn you, this episode has a lot of gravitational lensing news, so I'm hoping you're up for that. So you've got this foreground galaxy that is acting like a natural telescope lens for this object that is farther behind it. So what is this object? It is a glowing cloud of hydrogen and helium gas seen about 700 million years after the Big Bang. So this is exciting. Astronomers used James Webb to observe this gravitationally lensed cloud of gas. And when they made their observations, they were able to measure the rotation of the gas in the cloud and determined that it is rotating around something that has about 50 million times the mass of the sun. And so you've got a supermassive black hole with 50 million times the mass of the sun in a shroud of gas, of hydrogen and helium left over from the Big Bang. And so clearly this could not have happened through the standard building blocks, galaxies coming together. This is leading to the possibility that these supermassive black holes collapse directly, that they didn't go through the process of a star dying and then finding more black holes to merge with, that you just had a giant cloud of gas and it collapsed directly into a supermassive black hole. This is big. And if this discovery gets confirmed and if they find more examples, we might have an explanation for little red dots. We might have an explanation for where supermassive black holes come from. We might understand the very first stages of how galaxies came together. So I will keep you posted on this one, but this could be the story of the year. We've got more on this from Evan Goff. And I warned you, more gravitational lensing news. So here is another interesting object that was observed by James Webb. In this case, we've got a very faint object, which is an ultra faint galaxy seen about 800 million years after the Big Bang. And I am totally boggled by how hard astronomers worked to be able to get this image. So what you had, once again, was an object that was interesting to study, and then you had a galaxy that was in front that was acting as a natural telescope lens. In this case, it was magnifying the image of the background object by about a factor of 100. And so it's as if they got a telescope that was 100 times more powerful than James Webb to be able to assist in their observations of this cloud of gas. And so they dedicated 30 hours of James Webb time on lap 1B. And this is the key. They were able to do spectroscopy on this ultra faint galaxy. Spectroscopy is where you take the light, you break it up into a rainbow, and you're able to see the chemical abundances in this object. And they found that it had incredibly low metal abundance. So about 1/240th the amount of oxygen, say, in the sun. So it is very metal poor, mostly primordial hydrogen and helium left over from the Big Bang. And it's incredibly light, about 3,300 times the mass of the sun in the entire little galaxy. And most of that is in the dark matter halo that is surrounding this. And so you are seeing this tiny, wispy galaxy seen about 800 million years after the Big Bang, incredibly metal poor, and it would only be possible because of this gravitational lens that allowed astronomers to evaluate it. And this object seems to be a kind of classification that we're just discovering called an ultra-faint dwarf galaxy, that these seem to be almost hidden galaxies that are around us, and they're really hard to see because they don't have a lot of stars in them. They mostly are blobs of dark matter. Got a story about this from Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was even more evidence for dark matter. So thank you everybody who voted last week. We're going to put the vote to this week's episode. It's all ready to go into the post tab here on our YouTube channel. So if you want to participate in this, go into the post tab, find the vote, and then I promise you the YouTube algorithm will just keep showing these to you week after week after week. But subscribe to the channel. Click on the notifications bell. Obey the algorithm. So one of my favorite missions is TESS, NASA's Transiting Exoplanet Survey Satellite. And this is like a consolidation prize. You know, there was the Kepler mission, which was hoping to find another Earth, an Earth-sized world orbiting around a sun-like star in the habitable zone, but Kepler's reaction wheels died, and so it had to move on to a different version where they use the radiation from the sun to be able to balance the spacecraft, and they're able to stare at one location and look for planets around red dwarf stars, but they weren't able to find that other Earth. And then following in its wings was TESS, the Transiting Exoplanet Survey Satellite. And this has been a tremendous planet hunter all on its own. It began its operations in 2018. And so here we are 8 years after TESS launched. Man, time flies. It was done on a very low budget compared to Kepler and other planet hunting missions. And yet it has found hundreds of confirmed exoplanets and thousands of candidate exoplanets. And now we get this incredible all-sky survey of TESS. Like, think about how TESS works. It surveys the entire northern hemisphere of the sky, and then it switches and surveys the entire southern hemisphere of the sky, and then it switches back to the north and back to the south, and it's been doing this now for 8 years. It's got a tremendous amount of data gathered up. And so when you look at this image, you are seeing the sky, you're seeing the Milky Way, you're seeing the Magellanic Clouds. But if you zoom in, you've got blue dots for all of the 679 confirmed exoplanets, and then orange dots for the 5,165 candidate exoplanets. 8 years later, it's found so many planets, and the spacecraft is still going strong. So I'm sure we'll find even more. Got a story about this from Lawrence Tognetti. You've probably heard the saying that most stars are found in multiple star systems. That's not entirely accurate. Red dwarf stars are the most common stars in the universe, and they are usually singletons. And so most stars are by themselves. But sun-like stars, larger stars, often come in multiple star systems, more commonly than they are singletons. And so the sun is kind of weird that it's all by itself. And so astronomers have found many examples of binary stars and many examples of triple star systems. But now astronomers have found the most precisely aligned triple star system ever seen, where you've got two stars with roughly the mass of the sun and then a third star that is orbiting both of them that is about 10 times the size of the sun. And all three stars are perfectly aligned so that they are eclipsing each other from our perspective. It's the same technique for finding exoplanets, but in this case, you're using this to study stars that are orbiting around each other. And this system was discovered by TESS. So it's not just finding exoplanets, it is also finding stars that are transiting in front of each other. We've got a story about this from Mark Thompson. I hope you're enjoying this week's episode of Space Bites, and you probably had to watch an ad at the beginning of this episode if you're watching this on YouTube, but we have removed all the mid-roll ads, and in fact, we don't do any sponsorship messages on our videos. Like, we don't like ads. And we think that the better experience is to watch this without ads. In fact, there's a way you can watch our episodes without any ads at all. And that's over on Patreon, completely for free. You don't have to join our Patreon. You can watch it in an anonymous browser and watch the full episode. And to encourage you to do this, we put one extra story into this week's episode. And that story is about how scientists flew an aircraft through the plume of a rocket launch to measure the chemicals that it's polluting into our atmosphere. So I'm going to put a link down in the show notes so you can watch that episode over there and then just like get into the habit of watching our episodes first on Patreon. But this is just a fraction of all of the space news that we are covering on Universe Today. And I want you to understand, like, I am curating what I think are the most important, best space stories of the week. And that's what we're publishing on Universe Today. But it's like a lot. And so to bring it all together into one handy package, I write a weekly email newsletter that covers all of these stories. I write every word. It's completely free. You can sign up to my newsletter. Go to universetoday.com/newsletter. I'm going to talk about a really cool comment that we got from an engineer on the Dragonfly mission. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Bergetti, Brian Bode, Caroline, Chuck Hawkins, Commander Bielak, Dark Finger, David Gilson, and David Matz. Enthralling Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneCentForAnimals.org. Please follow my nephew at vbrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Franlin Munley, Team 49, Telescopes Canada, Vlad Cheplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we got this comment on a recent video where I was talking about what was happening with Dragonfly from Cover the Stone. I'm an engineer on Dragonfly. I'm so hyped. Now, just to warn you, I did not check the credentials of the person who posted this comment. I'm going to assume it's legit. You know, maybe someone is lying to me, but I'm just going to assume it's the truth because that is awesome. And man, it really warms my heart that somebody at NASA is actually watching our videos. And actually, we've gotten some really cool comments in the past from people who have worked on various missions. There was an interview that I did about liquid nitrogen being used as a way to remove lunar regolith from astronaut clothing, and one of the researchers who worked on that paper mentioned in the comments, and then I used that to interview them. And I've actually had a bunch of other interviews that have started from people who have posted into the comments. So this is more interactive than you think. And while I'm getting a lot of my news from journals, getting news from press releases and contacts that I have, I really do like it when researchers who are working on stuff have interesting stories to tell and reach out to me directly and let me know about their research. So I put my email everywhere. It's frasercain@gmail.com. You can also send an email to info@universetoday.com. And if you are working on a mission, if you've passed a really cool milestone, if you've got some insider news, if you've got scoops, I would love to hear them. And then I can do even better reporting on stuff that is exclusive. You might not know if the thing you're working on is as cool as I think it is. So just reach out. Man, I am glad to be back in my home office, no longer sort of crowded into a tight Japanese hotel room trying to record. So thank you everybody for your patience while I was gone for a couple of weeks there. We're back, tons of content. I'm not going anywhere for many months. All right, we'll see you next week.